Hi everyone, let's talk about lipids. Yes, I'm still sick, and yes, that is besides the point. This is based on the AQA spec point 3.1.3. Okay, let's get into this. So first of all, let's go over some definitions. Saturated, single/no double bonds between carbons. Unsaturated has at least one double bond between carbons. Hydrophobic, repels water. Hydrophilic, attracts water. Triglyceride, formed by the condensation of one molecule of glycerol and three molecules of fatty acids. Let me add an S to that. Phospholipids, one of the fatty acids of a triglyceride, is substituted by a phosphate-containing group. Moving on to some terms. You can use these interchangeably. This is probably more useful when we look at the cells topic, but it's just good to have an overall understanding of what terms mean the same things. So as we established before, hydrophobic means that it repels water, and as water is a charged molecule, therefore hydrophobic is synonymous with being uncharged. Once again, if it repels water, it is water insoluble, and being water insoluble in turn makes it lipid soluble. Hydrophilic is that it attracts water, and as water is a charged molecule, similarly, hydrophilic is synonymous with being charged, and so it is water soluble and lipid insoluble. And fatty acid, a notation for it can be RCOOH. Okay, lipids. There are two groups of lipids, at least, that you need to know: triglycerides and phospholipids. Here's a bit of extra info, but this is really good for those 25-mark essays you get in paper 3, so I definitely recommend you listen out for this part. Here's some extra properties for lipids as a whole. So this spans from phospholipids to triglycerides. One property is waterproofing. In plants and insects, waxy cuticles enable conservation of water. In mammals, oh my goodness. Secretion from the sebaceous glands. In skin, provide a defense mechanism. Another property is protection. It protects organs, i.e. the kidneys. And once we look more into the paper 2 topic, you'll understand this. Plasma membranes, this is a paper 1 topic as well, and we will get into that. It is a property of lipids, and it provides flexibility and the transport of lipid-soluble substances. Let me remove this part. Another property of lipids is insulation. When stored beneath the body surface, it helps retain body heat, and as myelin sheath, it acts as electrical insulators in nerve cells. Once again, those two will be really helpful in paper 2. And another property of lipids is it can act as an energy source. When oxidized, lipids can provide more than 2 times the energy of carbs of the same mass and release water. Once again, in A-level biology, you don't necessarily need to know any, I like to call these stats when I look at more GCSE geography. I would call that a stat, knowing specifically 2 times the energy. You don't necessarily need to know that in A-level biology, but once again, this just helps paper 3 knowledge. So back onto the main content. The characteristic bond of lipids are ester bonds, and to test for lipids, you use the emulsion test, which is you add ethanol, then water and mix, or you can say you add ethanol and mix, then add water. You do not use heat. And if a lipid is present, a white/milky emulsion is present. Do not describe this emulsion as cloudy or as a precipitate, as these are terms that are not favorable in the mark scheme. Moving on, let's draw an ester bond. If you are on audio on Spotify, we are going to skip past this part because you obviously can't see this, but definitely hop onto YouTube and you'll be able to see a full explanation on how you'd probably want to attack this in the exam if you are asked something like this. So let's get into drawing an ester bond. For this example, we are going to be drawing a triglyceride. So first of all, I'm going to draw a glycerol molecule. And as we established before, fatty acids have the structural formula of RC double bond OH. So we are going to draw 3 fatty acids now. And as always, a condensation reaction, we have to circle the water molecules. So I'm just going to circle each of the H2O groups that we are going to be removing. Put a little plus sign there. And as always, I always add my water molecules at the front so I never forget them. Remember, as it's a triglyceride, there are 3 fatty acids, so 3 water molecules are going to be removed. So do not forget to add the big 3 in front of the H2O. And now I'm going to draw the final triglyceride structure. Okay, and now I'm just gonna highlight one of the ester bonds just to make it clear. And similar to scientific drawings, I'm gonna draw a single solid line, no overlapping, no arrowhead, and I'm just gonna label this as an ester bond. Okay, so now we are going to be moving on to the main content of the topic again. So fatty acids, I mentioned they have a molecular formula of RCOOH. The R group of a fatty acid may be saturated or unsaturated. Further features of a saturated fatty acid R group would be its inability to accept more hydrogen atoms, and additional features of an unsaturated R group would be that the double bond makes the molecule bend, therefore it can't pack, making them liquid at room temperature. And I'm just going to grab my laser pointer here to point out on this diagram. Once again, if you're on Spotify, hopefully you can hop onto the video to watch this. If not, hop onto YouTube. And as you can see on this little diagram, as we mentioned above, unsaturated, the double bond causes the molecule to bend. So clearly here below we see there's an unsaturated R group, and then the 2 above are saturated. Okay, moving on to triglycerides, aka fats, which at room temperature are solids, and oils, which are at room temperature liquids. Fatty acids may be the same, so described as simple or different, and they can be described as mixed. In all triglycerides, the glycerol molecule is the same. Denotes they have 3 fatty acids, and glycerides means combined with 1 glycerol molecule. And on the video you can see this little diagram, which I think is adorable, on how to perhaps consider a triglyceride molecule in its most simplest form. Moving on to triglyceride properties, it is an energy source, has a high ratio of energy storing carbon-hydrogen bonds to carbon atoms. It is a storage molecule, so it has a low mass to energy ratio, so much of the energy can be stored in a small volume. It is compact. No osmotic effect, large non-polar molecule, so insoluble in water, and it is a source of water, has a high ratio of hydrogen to oxygen atoms that when oxidized releases water. Phospholipids, the difference in structure of triglycerides and phospholipids is the substitution of a phosphate-containing group for one of the fatty acids. So you get the phospho part that denotes that one of the fatty acids of a triglyceride is substituted with the phosphate-containing group, and lipids as is a group of lipids. So as you can see, once again, this adorable little diagram of perhaps the simplest form of a phospholipid, where you can see the phosphate-containing group, the glycerol. And I remember doing my exams, I'd always forget that there is still glycerol molecules, so just to see that highlighted in the middle is really important, and then the 2 fatty acid chains that remain. Let's move on to phospholipid properties. They form monolayers on surfaces. Let's delete that. Micelles slash bilayers on water, and they are polar molecules with a hydrophilic phosphate containing group slash head and 2 hydrophobic fatty acids slash hydrocarbon tails. And let me get my laser pointer back. They help hold surface of cell surface membrane due to the hydrophilic phosphate containing group slash head. Allows glycolipid formation by the combining with carbohydrates within the cell surface membrane. And let's do a quick comparison between triglycerides and phospholipids, which you may encounter in an exam. So when we look on the triglycerides side, some of the differences it has to phospholipids is that it has 3 fatty acids. It is a hydrophobic non-polar molecule, and it does not form a monolayer on surfaces or micelle slash bilayer on water. And some of the differences phospholipids have for triglycerides is that it has 2 fatty acids and a phosphate containing group. It has a hydrophobic slash non-polar and hydrophilic regions, and it is able to form monolayers on surfaces and micelle slash bilayers on water. And the similarities of both of these lipid groups is that they contain ester bonds between the glycerol and fatty acids. They contain glycerol. The fatty acids on both may be saturated or unsaturated. They are insoluble in water, and they all contain the elements carbon, hydrogen, oxygen, but phospholipids contain the element phosphate as well. So that is it with this revision video on lipids. I hope this was helpful. Once again, comment below if you have any more questions on the topic or any other related topics or any recommendations on other videos that you're hoping to see. Thank you and happy revision.